Hi, everyone. Thank you for joining today's webinar on SD-WAN transformation with LiveNX. I'm Monique Lucy, Director of Product Marketing here at LiveAction, and your moderator for today. Before we get started, I've just got a couple of housekeeping items to touch on. Our goal for these sessions is to foster communication within the IT and network management community and to offer some insight into solving the problems and issues that enterprise IT teams face within their network. During this session, please feel free to ask questions and to share your perspectives on what you see happening in the world. You can use the chat panel or the Q&A to send your questions, and I will address them with the panel. This session is being recorded, and we will post the recording to the LiveAction website in a few days. It will be under the resource menu in our on-demand webinars. Additionally, we're going to be hosting more of these sessions in the coming weeks. So if you don't get all of your questions answered today, or if you have more later on, you can always register and attend another session. If this is the first time joining a LiveAction webinar, I just want to make a quick introduction to LiveAction's network performance management solutions. Our solutions enable network teams to achieve operational and performance excellence to support the success of the business. With LiveAction, network management teams are able to improve application performance, accelerate troubleshooting, manage their network readiness, deliver major IT initiatives, and perform advanced reporting and analysis. On our panel today, we have members of LiveAction's sales engineering team. These are the people that are working hand in hand with customers every day to resolve the toughest network issues. We'll hear from David Izumo, Principal Technical Marketing Engineer, and Alex Cameron, Sales Engineer here at LiveAction. Welcome, everyone, and thank you for being with us today. David, Alex, please introduce yourselves and give us a little bit of your background.
Sure. Thank you very much, Monique. Hello, everyone. My name is David Izumo. Like Monique was mentioning, I'm a Principal Technical Marketing Engineer. I've been with the company for quite some time, from right about the very beginning of LiveAction. So it's been awesome to see the growth and working with a lot of our customers to ensure that they have a high quality of experience. So we're looking forward to the discussion today. Thank you for joining us.
Yeah, hi, everybody. My name is Alex Cameron. I'm one of the sales engineers here at LiveAction. I've been with the company not quite as long as David, but very long myself, helping many customers understand the value of SD-WAN throughout their environment. I help some of our largest customers deploy and use SD-WAN within their environment. So great to be meeting you and talking with you today.
Thank you both. IT organizations are adopting disruptive technologies to support digital transformation. But can network operations teams provide their organizations with enough visibility to enable data-driven change initiatives? The network is essential to any digital initiative, and any change to digital services will impact that network. Infrastructure initiatives such as new application rollout, cloud migration, or SD-WAN are often done as a replacement to existing infrastructure. So proper planning is key, since network operations teams must provide guidance for planning, implementing, and validating a change to digital services, all while supporting ongoing optimization and management of digital infrastructure. And poor planning of new digital initiatives can damage the overall success of an enterprise. It also places a heavy burden on network operations teams who are tasked with supporting these poorly planned transformations. 1/4 of enterprises say poorly implemented infrastructure projects are highly disruptive to network operations today. Failed projects rank 6th among network operations challenges, and failed infrastructure projects are the 3rd leading challenge to network operations success. Today's software-defined wide area network, or SD-WAN solutions, provide good native visibility into network overlays, but they often lack the visibility into end-to-end WAN performance. So I'd like to give you just a quick high-level overview of what is involved at each stage, and then I'll turn it back over to David for a deep dive and product demonstration. During pre-migration, a network performance management platform can measure the capacity requirements of the existing WAN. This includes a comprehensive analysis of site-to-site, site-to-data center, and site-to-cloud bandwidth consumption. During the deployment phase, the network operations team should also verify that the new SD-WAN solution will provide sufficient hybrid cloud WAN capacity across the network. And then lastly, in the post-migration phase, network managers must monitor the health and performance of the hybrid connectivity. So now I will hand it over to David, who will take you through each of these phases in a live demonstration.
Thank you, Monique. Let's see if you can pass me the ball. Okay, great. So we can all probably agree that SD-WAN is extremely important today. It's pervasive and it's a hot topic on the minds of our customers. In fact, most likely many of you are researching SD-WAN benefits or actively deploying it, and perhaps many have already operationalized SD-WAN and are seeing its benefits. There have been also major acquisitions recently, and you most likely heard about it in the news. A couple of years ago, Cisco bought Viptela, VMware acquired VeloCloud, HPE bought Silver Peak, Palo Alto Networks acquired CloudGenix. According to one study, in just 2 years, 94% of organizations will have deployed SD-WAN, and that probably includes you too. As Monique brought out earlier, many SD-WAN vendors provide visibility also into the WAN, the site-to-site tunnels and their performance by means of their controller. But the network is much more than just the WAN. Even though it's extremely important, NetOps teams need to troubleshoot and operationalize the entire network. So typically the visibility from an SD-WAN controller is confined to everything within that blue box that you see in the middle, right there. LiveAX provides true end-to-end visibility from the hundreds or thousands of branch offices that you may have within the enterprise, the large campuses, site to site across the SD-WAN fabric and into the data center and the cloud, whether that be IaaS or SaaS services. According to that same study, 93% of enterprises have a multi-cloud strategy. So LiveAX not only provides visibility into your on-premises infrastructure, your routers, your switches, firewalls, load balancers in the data center, but also your infrastructure in the cloud. And those are pieces that you control, but perhaps you may not own because it's owned by the cloud provider itself. We have support for cloud monitoring for AWS and Azure within LiveAX today. In fact, we recently did a webinar on LiveAction LiveAX Cloud Monitoring, and I encourage you to revisit that session too. Simply go to liveaction.com for more details. LiveAction has helped hundreds of customers overcome migration challenges and successfully deploy and monitor SD-WAN. So the approach that we take is a day 0, 1, and 2 approach, and I'll dig in further into the details. Day 0, the planning phase, is extremely important, and it really cannot be overlooked. This is where we help to baseline and assess the current network. Perhaps the enterprise is transitioning from traditional WAN with MPLS circuits, or maybe even Cisco IWAN, which is the case for one of our very large international customers right now. We're helping them migrate from Cisco IWAN to another SD-WAN solution. We can help benchmark the applications, performance, and provide visibility into areas that may not easily be apparent at first. Shadow IT is pervasive. For example, a business unit may have deployed a critical cloud application without the IT team's knowledge, and now the NetOps group must support that moving forward. Understanding which applications are currently on the network, which sites they're originating from, and baselining its performance helps with the next step, and that's day 1. So day 1, the verification phase, is about validating SD-WAN policy and ensuring that network intent is met. With the application baselines we learned in day 0, we can now apply that to policy deployment and verify application-aware routing and per-segment topology validation. What I mean by per-segment topology validation, think of segmenting the network by means of VRFs or service VPNs, and then verifying that that topology is actually in place and the traffic is flowing over the different transports according to the policy. Day 2 is all about operationalizing SD-WAN within the existing network. Multi-vendor visibility is critical. There may be a Cisco in the campus and the SD-WAN environment, for example. Palo Alto or Fortinet firewalls for security, and F5 load balancers in the data center, and maybe DevOps teams are deploying workloads in the cloud. NetOps teams need visibility across the entire network. To provide this visibility, LiveNX consumes many different forms of telemetry from the network, and I'm going to dig into that a little bit further from an SD-WAN perspective. Ongoing performance analysis, faster mean time to resolution diagnostics, along with capacity planning, alerting, and reporting is a must. Some customers that we've worked with in the past, well, they tended to blame the newest thing that was added to the network with the least visibility. That cannot be the case with SD-WAN. Full visibility is absolutely necessary. So let's dig into a bit of the technical details. LiveNX will consume multiple forms of telemetry to operationalize SD-WAN. So let's take a look at Cisco SD-WAN as an example. So from the edge devices themselves, whether that be a vEdge or a cEdge in a Cisco environment, we'll be able to make connections via SNMP, and that'll help us understand the overall health of the device, CPU, memory, interface utilization, and so forth. Likewise, we'll collect flow data directly from these edge devices, exporting to LiveNX. So that helps us understand conversational information, the applications, which transport the traffic is taking across the network, whether that be MPLS, the business internet path, or maybe LTE as a backup. Likewise, LiveNX will make northbound REST API connections to the controller, in this case, vManage. And we're able to pull in telemetry like BFD data for bidirectional forwarding detection, for overall site-to-site tunnel health, the inventory for easy onboarding, application data, as well as alarms. Likewise, we can deploy our LiveWire and LiveCapture products in the enterprise for packet capturing technology. And we have very unique workflows where we can take packets and automatically convert that to flow information for high-level visibility. But where that's key is also providing application performance metrics as well. So typically, the SD-WAN vendors are going to give you data about the conversations. But being able to dig in deeper by means of the packet data to gather application performance metrics for your critical apps or your real-time apps like voice and video is key, including getting things like MOS scores, loss latency, and jitter. And this will help with multiple use cases: policy verification, SLA performance, app route changes and alerts, site and tunnel performance, as well as cloud on-ramp to various things like IaaS or SaaS. So let's look at one example case study. A large hybrid cloud leader leveraged LiveNX to transform their network. They used LiveNX during the SD-WAN migration to help baseline their current application health and load, thus being better prepared for their SD-WAN deployment, including service provider load, application latency, which application should get preferential treatment, and QoS health. By implementing and using LiveNX, they were able to achieve their network transformation months in advance, saving the organization millions in MPLS provider and service engagement costs. Additionally, we improved their mean time to resolution by 60% over their previous network design. So with that, let's switch gears and let's dive into a live demonstration of LiveNX with SD-WAN. So this is LiveNX. We call this the engineering console, where you can take a deep dive into your entire network for visibility. Now, you can think of this engineering console like a dynamic whiteboard or a dynamic Visio diagram. The main goal for us was really to try to recreate the mental model of the network engineer, the way that you think about the network. So notice that there's a bunch of different circles here, and I'm going to zoom into this topology just using the scroll button on my mouse, or you can leverage these magnifying glasses in the upper left-hand corner. Now, these big circles represent routers, switches, or various network devices. So in this case, these are edge devices for an SD-WAN environment. The little circles inside, well, that represents interfaces. So notice that this is Gigabit Ethernet 01. The top portion is ingress bandwidth, and the bottom portion is egress bandwidth. So very quickly and easily, you're able to understand how this network is put together. And normally, when you're working on a network, you're going to go to that whiteboard, you're going to draw a bunch of circles, and then interconnect them, right, as devices based off of the network. So notice that these devices are all interconnected by their subnets or perhaps by their service provider networks. So in this case, there's the MPLS provider on the left-hand side, as well as the internet provider on the right. And because it's dynamic in nature, you can move these devices around, the cloud networks and so forth, again, with the goal of recreating the way that you think about the network. Now, all of the different colored lines that you see running over the top is indicative of the conversations, the IP fixed data, the flow data coming from the devices themselves. Right? So we support many different flow technologies, including NetFlow, version 5, version 9, IPFix, as well as SFlow. And it'll all be overlaid across this network in the same way. So in this case, we're looking at all of the colors, these flow conversations, based off of DSCP. You can change that to high-level application visibility as well. Now, by double-clicking on a particular device, perhaps this device in Chicago, will take you into the real-time device view. So all of this visibility is coming in pseudo real time. The device is exporting flow data directly to LiveNX, and you're able to see the applications, the conversations, and so forth. And notice by simply clicking on one of the rows in the table, it'll automatically highlight that down below. So you can see that this traffic is coming in on a particular interface and going out another. Also, you can click on playback, and that'll bring up the same view, and you can go back in time to look at the different conversations over time. For example, just looking at the calendar, maybe yesterday at a particular point in time, and simply clicking playback, this is just like a network DVR of sorts. Now, with LiveNX, you can dig into all of these details with this engineering console, track the different conversations using a table view, and then identify those conversations across the topology. But what I'd also like to do is dig into our operations dashboard as well. Day 2 ops, it is extremely important. You need that visibility from dashboards, reporting, and various other workflows. So I'll switch gears, and I'll move over to our LiveNX web UI, our operations dashboard. So notice here that you see all of your sites, your devices, your interfaces, as well as active alerts that are coming into LiveNX and also being generated by LiveNX. So with the case of SD-WAN, we can be pulling in alerts directly from the controller. So notice also that I can click on a particular site, like perhaps site San Jose, and that'll automatically allow me to drill in to that site view. So notice top-level information about your service provider bandwidth, inbound as well as outbound. And notice that from the service provider perspective, we're seeing a lot of traffic moving from business internet over to the MPLS circuit, as an example. Here's your application data, inbound and outbound, and so forth. Likewise, we can drill down into a particular application. So in this case, Voiceover IP is absolutely important. Now, from the perspective of San Jose, we can see that this Voiceover IP traffic is moving from that San Jose site and these edge devices off to various service providers like business internet and MPLS, and then off to various remote sites like Miami as well as Chicago. So you can dig into the details to better understand the top conversations for this critical application, as well as the DSCP markings as well. What I'd like to do is I'd like to also drill down into our GeoTopology. And the way that you're able to do that is by clicking on the menu bar in the upper left-hand corner, going to Topology, and then selecting GeoTopology. We'll automatically bring up the GeoTopology within LiveNX. So let's dig into a couple of use cases. So what you're seeing here is those same sites that we saw on the engineering console, including San Jose and RTP, our 2 data centers, along with 2 remote branches, Chicago and Miami. Now, what we have is we're overlaying flow or application data over the top. So notice that you can see SAP or Office 365 by simply clicking on the applications in the legend down below. Likewise, Voiceover IP as well. Now, from a Cisco SD-WAN perspective, you can also click View Policy, and we're going to bring up the policy that's deployed within vManage. So notice in this case, we have 2 SLA classes that are set up, one for web SLA and one for voice and video. And notice the latency setting is for this threshold for voice and video is set to 50 milliseconds. For voice and video as well, the preferred color is MPLS and the backup is business internet. So with this in mind, let's look into how we can verify the topology, perhaps on a per segment basis, as well as looking into your critical applications from a quality of service perspective as well. So with this filter bar in the top, we can ask LiveNX questions. So for example, perhaps the primary segment that I'm looking at is VRF10. So I'll look for VRF10, apply that filter, and we're going to look at all the application traffic on VRF10. And there's all the applications. Now, perhaps I may want to drill into a specific application, a critical application like Voice over IP. You can select application as a filter, and I'm going to just type in VoIP. This particular application is a custom app that's defined within LiveNX. So you can define custom applications based off of IP addresses or ranges of IPs, port numbers, URLs, as well as SSL common names, or various other application IDs also. So I'm going to apply this filter, and what we're going to identify then is all the voice over IP traffic for segment VRF10. So there we can see that really VRF10 is fully meshed, especially for a critical application like voice over IP, moving across these primary sites like San Jose to Chicago to Miami and then back again. Now, a big piece of understanding and making sure that voice over IP is working correctly is quality of service. So you want to make sure that you have consistent DSCP markings across the board, across the entire topology. Notice that we can change the display by to DSCP. So in this case, we're providing that same context. We're looking at VRF10 for application voice over IP. Now, these types of workflows will work with many different SD-WAN vendors that export IP fix or NetFlow directly to LiveNX. So now notice that for voice over IP on VRF10, that the DSCP marking is EF. It's consistent. And that's the best practice for voice over IP. Now, if you see different sites or different pockets of the network where you're seeing EF traffic along with best effort traffic, which will show up as a different color, then you know that you're having inconsistent QoS in different parts of the network. So far, everything is looking really good for voice over IP. But now you bring in the SD-WAN portion or the SD-WAN piece. And that means that SD-WAN is going to steer that traffic over different transport paths, service provider paths, based off of performance. So let's change the display by in the legend down below to service provider. So notice as I change that to service provider, we have the same context, VRF10, voice over IP traffic is what we're looking at specifically on the GeoTopology. And notice that we're seeing a lot of MPLS, right? So voice over IP is taking that primary path, MPLS. But notice also that for this time period, which is 1 hour, we're also seeing a lot of that traffic taking the business internet path as well. But according to the policy that we looked at earlier, the policy says that voice over IP should prefer MPLS. And then the backup is business internet. So what's happening in this case? Well, let's look at another use case where we'll be able to drill down in 3 clicks to better understand exactly what's happening. Why did this traffic get moved? So I'm going to reset the GeoTopology just a little bit. I'm going to set that back to WAN applications. I'm going to go ahead and clear these filters and then apply that filter. So now we're seeing everything over the top again. So again, we can click on these various applications like Voiceover IP and just see that on the topology. But notice also that there's these dashed lines going from site to site across the topology. And then from San Jose to Chicago, it's showing up as red. You can click on that dashed line, and this is indicative of the aggregate tunnel performance site to site from San Jose to Chicago. Here we're showing you your various SLA classes for voice and video, and then tying that back to the service provider performance for business internet as well as MPLS. So notice that business internet is all green. Everything's looking very, very good. And you can just mouse over those cells. And notice for voice and video, you have 2 milliseconds of jitter, 0% packet loss, 2 milliseconds of latency. Everything's running really well across the business internet path. But the MPLS circuit, which you're paying a good amount of money every month, notice that we're seeing high latency. That's showing up as red, over 200 milliseconds of latency. According to the policy that we looked at earlier, the threshold is only 50 milliseconds. Notice also that jitter is showing up as 23 milliseconds, and packet loss, though, is showing up as 10%. But packet loss is showing up as green. The reason for that, even though there's high packet loss, is because according to the SD-WAN policy, it didn't include a threshold for packet loss. It was primarily focused on latency. So this gives you a high-level overview of the tunnel performance site to site, broken down by your various classes. But we can drill in further by simply clicking on this little button here, and this is your second click in troubleshooting what happened with regards to your traffic moving from one provider to the next. So we'll go ahead and click on that button there, and we'll bring up the site-to-site Sankey diagram. So this is site-to-site from San Jose to Chicago. And we show you all of the applications on the left-hand side, the segmentation for VRF, the DSCP marking for QoS, as well as the service provider path that it's taking. And then likewise, the status on the far right-hand side. Now you can look at a particular application like VoIP and then track that across the network to see that it's being marked consistently EF and taking 2 service provider paths over this 1 hour time period for MPLS as well as business internet. And then likewise, you can click play and it will play back all of this traffic for you. So you see that the traffic is on MPLS and business internet. MPLS is going to turn red, and then that traffic is going to go over to the business internet path. So here we can get a better understanding over time of how traffic is being flipped or routed across our various transport paths, site to site. You can likewise leverage similar filters on this view to specifically look at a specific application or a service provider, VRF or DSCP. Or quickly, you can just simply use these little drop-down menus and perhaps focus on Voice over IP as an example. All of this is right there at your fingertips. Now, the third button click to troubleshoot this network is I need more details. I need to see reports, application reports, conversation reports, and performance information as well. So the way that you can do that is simply click on these service provider bars. Any one of these bars here, you can click down and drill down further. I typically like to click on the service provider bars, and that gives me a whole host of reports to better understand what's happening. So let's click on MPLS, and that'll bring up a whole set of reports. Now again, we see the same context, San Jose to Chicago, and this time we're looking at the MPLS provider. So here's the application report for MPLS. So all those applications are on MPLS, it falls off, and it starts coming back up again. For Voice over IP, Citrix, Hulu, SIP, various other types of applications are on this network. And then likewise, here's the DSCP markings, site to site, on the MPLS provider. And again, we see my voice over IP traffic being marked EF, along with a lot of traffic being marked best effort. Now, as I scroll down further, here's the top conversations. And then likewise, at the bottom, your performance metrics for jitter, as well as loss and delay. Now, notice for delay at the very bottom that this is actually a critical issue. Why? Because delay is at over 200 milliseconds of delay. Now, where there's high delay of 200 milliseconds or so, that's when that traffic is going to be pulled off of MPLS, right? So notice that there's high delay, 200 milliseconds, it drops down to just about 1 millisecond or 0, and then back up to 200 milliseconds. But as I scroll up to the top, notice that where there's that low delay on the network, that's when we're seeing all of that application traffic on this site-to-site connection for MPLS. Notice that it's the exact mirror image for business internet. So where business internet is showing you all of your application traffic, it's the exact mirror image with MPLS. So this is a three-step process that we can leverage LiveNX on the GeoTopology, getting an understanding of the various applications that are running within the network, drilling down on a particular site-to-site tunnel to better understand where that application traffic is flowing, and then likewise down to your various reports to get more details, more visibility about the applications, conversations, as well as the performance. LiveNX has a whole host of different reports that are available to help you make sense of the network. Now, a couple other things that I want to touch on in this operations dashboard is likewise our path moving forward to help you understand the logical topology. So LiveNX, for many years, we've been actually quite well known for our visibility here, right, on our engineering console to understand your hop-by-hop traffic throughout the network and overlaying flow over the top. Now, for day two operations, your NOC engineers, you may not want them to have full access to or look at this topology because it may overwhelm them. They may have too much information with all of the flows going in and out of the system, right? But perhaps for an operations perspective, they may also want to have that visibility from a logical topology perspective. LiveNX allows you to do that too. So you can click on this menu bar, go to logical topology, and you can lay out various sites of interest. You can have various tabs for different sites that you want to put within this logical topology. So on this tab, I set up my 4 different sites, Miami, Chicago, San Jose, and RTP. And we'll lay that out, and you can unlock this view, and it's, again, very dynamic in nature to move things around along with your service provider tabs as well. There's all your application traffic, so voice over IP. For this period in time, notice that it's taking the MPLS path here. Right? You can likewise expand these sites, and we're going to open that up to show you the different devices within that site. And then if you have live wires within that site too, you can drill down and then identify from flow all the way down into the packets. Now, one last piece on this demonstration that I'd like to talk a little bit further about is also ongoing capacity planning. That's extremely critical for day two operations. So LiveNX allows you to have that too. Capacity planning, 95th percentile utilization reports for your various service providers, and then you can drill down to get into the nitty-gritty details over time. And again, this is to help keep up with the demand on the network, to help you better plan for upgrades from your service provider transport perspective. So with that, I hope that helps you understand what we can do from a LiveNX perspective, giving you that unmatched visibility for your SD-WAN environment. And with that, I'd like to turn your attention back over to Monique for some concluding slides.
Thank you, David. Great, great information you provided there. So as we've discussed through David's product demo, SD-WAN has emerged really as a game changer for distributed networks to address the demands of digital transformation happening across many organizations today. To support emerging architectures without compromising user experience or straining resources, IT leaders need clear migration paths that de-risk the adoption and governance of the latest technologies. Integrated, validated, and easy-to-use solutions that simplify the management of increasingly complex networks and extend network technology investments have high value in today's enterprise environment. So how does LiveAction help network teams? We provide visibility at all levels. We consume more data at a more granular level than anyone, allowing you to start globally and then drill down to a location, a single hop, a packet, or even a phone number, all from a single pane of glass. So LiveAction provides end-to-end network visibility across the entire network, including campus, branch, data center, public cloud, WAN, SD-WAN, and we're vendor agnostic, offering the broadest support of key network vendors. And we also offer the broadest telemetry, including NetFlow, Packet, SNMP, API, IPFix. And we have an enterprise-scale platform with real-time and historical monitoring without compromise. We provide unmatched data fidelity and the finest level of granularity with predictive analytics to proactively identify, troubleshoot, and resolve network performance issues, leveraging both ML and AI. So I will pause there, and I see that we have a few questions that have come in via the chat. Let's see. The first question that we have here, this is a good one. I've deployed SD-WAN, and I'm also moving workloads to the cloud. What visibility do you provide for AWS cloud monitoring? Alex, can you take that one?
Yeah, we've recently released our cloud monitoring. So now we can start to see inside of like Azure, and we're able to see a start of AWS. So we can start monitoring like your VPC, seeing the networks inside of it. So as you had your previous load of traffic on your traditional network and want to move it to the cloud, we can start to visualize the traffic that's there, see the load, and see if traffic's being rejected across multiple service providers. So as you start to transition to the cloud, we're going to get that visibility that you need to see how your applications are performing.
Oh, that's great. Thank you, Alex. Here's another question that just came through. Would LiveAction be used to help select my initial SD-WAN pilot sites? I want to try out SD-WAN, but I'm not sure what locations in my network would be best to start with. What could I learn before deploying my policies?
Yeah, this is a great question, and actually this is one I'd like everybody to take a little bit to heart, because as I've worked with many customers like yourselves, as you go through and are deploying SD-WAN, you have your policies in place and you don't know what you're doing. You kind of get recommendations from Cisco's best practices, but remember that's not your network. Your network's unique and going to be different. You'll have different applications. So kind of building off this question, these are things that are going to be critical. We're going to be able to look at some of those key locations. Which sites have our important traffic? Is it being overloaded? Do we need to actually offload that onto another service provider? What applications are out there? If we start to have certain applications prefer one service provider or the other, then you're not going to really be able to understand the load that you're going to deploy across your SD-WAN environment. And things, again, like being able to look at sites. I've seen sites before where a lot of the traffic's unnecessary, so we're going to add that extra circuit there when we don't need it. So being able to see what applications folks are using. We can use the data you have today by bringing in routers like ASRs, ISR 4Ks, switches, multi-vendor devices, so we can start to look at the performance site to site. So as you build up your policies, you're going to say your voice traffic can have this much of performance degradation. But what happens if you're deploying your SD-WAN and you're already having that much degradation in the network? So your traffic just fails from one to the other. So having an idea of how your sites look, what the load of traffic looks like there, what performance I already have there. I mean, I see lots of partners of ours that like to sell this to you as a service, but you can honestly use LiveAction, start looking within your own environment, and then be able to have good ideas about how my policies should be built out according to my real traffic inside of my environment and what sites need to be identified first. So very, very key that you have this eyes in your network before you start putting something complicated on top of it. So very good question, and we're going to give you a lot of data to help you identify the load in your environment and the performance of site-to-site information.
Thank you. Here's another one. How does licensing to the cloud environments work? Do I need a license for each VPC?
You'll need a license for each VPC, and then there's also another count that we have. So it's called a CEC count. It's pretty much how many networks do you have within inside of your VPC. So these two will help to define your cloud sizing. It's also, just to call out, not a device. If you have LiveAX, it's not just adding a router into the system. It's going to be deploying a cloud monitoring module, and then we'll start talking to your VPCs and bringing them in. This is a discussion you should have with your sales manager for sure, or you can have your regional sales manager reach out to him, and we can help you come to identify what that cost would look like. But there are a few things to consider for a cloud deployment.
And then another one here, is LiveAX an option to monitor BGP terminate at Palo Alto firewall?
David, you might know there better than me. I don't believe so, but I guess we could see the BGP records coming in and the flow data, but LiveAX would be required to monitor that information. We could see the transactions of BGP back and forth across the devices, so those are information that we could see, but we would need them added into the system to be monitored, if that makes sense. So yes, they're a supported device in LiveAX, and we could monitor BGP from a NetFlow perspective.
Yep, definitely, Alex. Yeah, so for the Palo Alto firewalls, we do pull in all of their IP fix records or their flow records. So it's going to be primarily from an SNMP overall health of the device, along with flow information. With Palo Alto firewalls, we also get not only just the conversational data, like source and destination IP addresses, but also application information and further information about the firewall actions, like rejected flows and so forth. So good question. Thank you.
All right, I think we have time for a few more questions. Here's another one. I've been concerned that I may have been too aggressive with some of the policies and may find it hard to tell if my voice traffic is on my main provider or my secondary provider. Does LiveAction have alerts to help quickly identify when these issues occur, or maybe reports to show service provider load per application?
Yeah, and David did a fine job of presenting that to an extent. So he went in and showed you the information and showed you how we could fail over between service providers. And you can do that very specifically on your voice application or other key apps that you would have within your environment. So most definitely we can present that in topology views. That information is available within reports. But again, maybe something we didn't get too deep into is we do have great alerts within our system. So situations like traffic failing over from one service provider to another, or not the correct amount of load of traffic on one service provider as we'd expect, or we can pull in other issues based on BFD about your policy and how they're performing. So that information can be exported as alerts via email directly to you if you're so interested, or syslog exports, or SNMP traps, or we can also export them out via ServiceNow integration. And things like this will include report links. So if you want to validate when there was a problem with one of your SLA classes that your traffic moved correctly over to the other service provider, in the alert, we'll have that details for you, so you won't even have to dig deeper into the system. So we definitely have dashboards, alerts, reports, visual ways to present how your SD-WAN environment is doing. And when those situations do come up, we can alert you or show you many visual ways how your traffic's performing. One of the things I always find when I work with customers is building that confidence into how your data should behave. So when David showed you, yeah, there was a problem with my traffic, you know, now, guys, it's not bad for your traffic to move from one service provider to the other if all your policies are working as expected. So you should see traffic move from one to the other, but do you have confidence that the correct applications are behaving in the way you'd expect? So alerts and the visual waves are going to bring you down to that confidence that your network's working as expected. So great question and things we can definitely help out with.
Well, thank you very much. I think that wraps up the questions at this point. So get the full picture and SD-WAN insights to deliver the best possible SD-WAN transformation experience. And you can do that by taking a look at this session again, the SD-WAN transformation session, or you can get a one-on-one LiveNX demo session or download a free trial of LiveNX. And you won't want to miss out on our next webinar, which will be on accelerated troubleshooting. So thank you very much for your time today. Have a great rest of your day. Bye-bye.
Thanks, guys. Bye.